Welcome to all petroleum engineers and students from around the world. In this event that brings together several countries, including Greece, Egypt, Britain, Germany, Yemen, Azerbaijan, and more, in one form of knowledge exchange and mutual development. Our tenth session, the training session, will be titled as a digital oil field. This session is provided by Mr. Abdullah Al-Hirz. Mr. Abdullah Al-Hirz, uh, a small brief, a small and a part of our lecturer experience. Mr. Abdullah is a reservoir engineer with over 13 years of expertise in oil and gas sector. Mr. Abdullah has the ability to utilize a proficiency in web development and data analytics to create advanced digital tools tailored for the oil and gas industry. Currently, he is working surveillance engineer and data analyst at ExxonMobil. We are here delighted to have you, and we hope to enjoy every minute of this session. I myself will enjoy it, and I hope the other will enjoy it too. So, Mr. Abdullah, you can go ahead and start the journey, and we will be listening to you. Thank you.
Thank you, Haider. Assalamu alaikum. Good afternoon, everyone. My name is Abdullah. As Haider introduced myself, thanks, Haider, for all the words that you said about me. First of all, it's honor for me, to give this brief presentation for all the people here to talk more about the digital oil field, how we can, nurture or using the cutting edge technology that all the big companies provided to us to utilize these technologies and get some benefit from that one to enhance our production optimization and reduce the downtime and the bottlenecks that we have. So we will go through these slides and talk more about these kind of technology, this kind of terminologies, how we can, first of all, define and understand what is digital oil field and how we can utilize it, not only in Iraq, I mean in all the countries and all the oil fields that can utilize these technologies. So I will start briefly about, I will go back a little bit about since 1970 up until now. So you see this chart, which is demonstrating the transistors as we call it more low. So you can see the transistors increasing per each CPU that you are utilizing in your phone, in your computer, and in all the smart devices that we have it now in our life. So you can see since 1970, the number of transistors now it's up to 10 billion of transistors per chip. So you can see how these computers, get more power like not have it before. So in this chart, we can say this is the kind of a historical illustration about why the digital oil field now exists in our life. Why the digital oil field was not exist like 20 years ago or 30 years ago. It's the answer is kind of like coming from three parts. Like first of all, the ability of the machines or the computers that we are utilizing in our working in the oil and gas
Mr.
industry.
Abdullah,
Like,
I'm sorry for
yes.
the interruption, but can you zoom the presentation? People are asking to zoom it.
Oh, okay.
Yeah. Thank you.
Let me do something here. Give me 1 second, Haider, just to set up something.
You can take your time. You can take your time.
Okay, because I'm presenting my machine on long screen, so maybe that's the issue. And now I disconnected. Now I will utilize. So what about now? Is it good now or still?
Yes, it's good. It's good. I can read it. Yeah, you can go ahead.
Okay, okay, perfect. So this chart can, as I said, like this chart can give you the number of transistors that now each smart device have it. So this is one of the okay, why the device now have the power to utilize all the calculations and all the graphics that can be presented to our screen or to in our phones. This is one of the answers. And if we go now to the second part of that one is the revolution of smartphones. It's not only the smartphones, even though the computers and when this brilliant guy, when he came with iPhone. So that one is not only iPhone; it's a revolution. It's what you call it. It's a full band of powers that he bring it to us, like how we can minimize the size of the devices. Like 40 years ago, 50 years ago, the computer was hosted in a room. But now each one of you now have a phone which is have the same power of the computer. And even though each one of you have a computer, like have ability to do sophisticated calculations or making sophisticated charts, or even though making simulation on the models using the commercial softwares in the oil and gas industry. So all that one was not exist like 30 years ago, but now it exists and you can utilize it even though more. And if we go more on that one, so we will go into the cloud, but so now everyone can run the simulation model through via his phone or his tablet. No need even though for a powerful computer to utilize that one. So you can open your phone and run your simulations, even though to see what is the result on that one. So that one was not exist 30 years ago. So we can say it about the power of the machines, the revolution of developing data machines, and even though the next one is the data. So this is one of the most important revolution, remark in our centuries, which is the data. And even though the Economist, which is one of the most important magazine in the world, especially for the economic world economic. So they said in this cover in 2017, data is the new electricity. So now you can see in the main page they put here not ExxonMobil. They didn't put here PP, or even though the big seven, let's say the big company oil and IOC companies, they put Facebook, Google, Amazon, Tesla. You can see here. So this is the revolution. This is how the world now will like getting more value from the economy. It's using data. So I believe all the audience here they saw in the last year how much ChatGPT changed the world, and how all these companies now moving forward more on the AI, and they're relying on AI. And I read many books on that one about the CEO and all the big companies in the world. Like all of them now, the main objective for them, how they can add AI, artificial intelligence, in their products, in their products to the people, so they can make it more value. Like you see my presentation now, I'm using Canva to prepare this presentation. Like this feature was not exist like last week. So now when I open it, there is here they call this magic switch. When you click on this one, it can translate your presentation in 1 second, or in maybe in 5 seconds, to any language that you want in your presentation easily. When you click, you can translate all your presentation to Arabic language or to any language, or even though you can make summary or make a post from that one, or even though you can ask Canva to make any slide or any post for you for any specific situation. This one was not exist in a week, but now when I open this application, now it exists. So you can see, and I can see And all of you now seeing that one, like all the applications now have AI abilities. Like they are trying, to maximize using the data that they have it to build on top of it a smart, more smart devices or more artificial intelligence devices, so they can, get their application get more value on that one. And I have seen that one not only in this specific application. I have seen this one now in the oil and gas industry. There is a lot of commercial application now existing utilizing AI, to do seismic interpretation, to do what we call simulation, reservoir simulation, like based on AI, not based on physical calculation. So that's maybe within after a year, you will see AI more involved in our life, not only in the oil and gas industry, even though in our homes, in our cars, and you can see Tesla now making self-driving cars. So I believe this is the way, like how the world now existing. Like they are utilizing all the data that they accumulated since 20 years or since the last 20 years or 30 years to build AI applications. So this is the three reasons why now the digital oil field more exists in our life. Why is not now is necessary. So we start with the power of the chips or the transistors per each smartphone, and we have seen the revolution of that one. The second one is the data that we accumulated in the last 20 years, and now we have more databases, we have more clouds, and so they host it. Even though if you put a like on the Facebook, they will count that one, and they will build a, a, AI model for you. So the third one is the revolution and the development that exists in the last 15 years on the algorithms and the machine learning algorithms, so they can utilize it to build sophisticated models like some of you maybe about machine learning. Now it's our presentation is not about machine learning, it's about more about digital oil field, but it's good to know about that one. So now we have more algorithms to answer or to build a model on, let's say, the self face recognition, or maybe regression in general, or classification, and all the details of the machine learning. So all these technologies was not exist like 30 years ago, but now it exists. So that's why now the digital oil field exists in our life. Now I will jump to this one. So like in one, let's say, sentence that we would like to say, digital transformation or digital oil field is not easy word, like to say. It is not like you are opening your laptop, or you are opening your smartphone to see a dashboard like presenting how much oil production you have, how much downtime you have, or downtime events, or maybe alarms that you set up. It's not like that easy one. It's not like that screen that you have seen. Like the life cycle of the oil field. It's starting from drilling rig up to flow lines, and go to a refinery or to the gathering station, then go to the export line. So it's not easy like answer for that one. So it's a lot of a process. It's a lot of infrastructure that you need to build. And top of that one, you need a lot of discipline, expertise from a lot of different fields to build that digital transformation. Let's say an example dashboard. So you need all these people integrate together to build a sophisticated dashboard on that one. So it's not easy answer for that one. It need a lot of investment, need a lot of effort on that one. You need time as well, and to build a digital oil field in your work, or in your field that you are working on. So as we said, like digital oil field, this is what we call the definition of the digital oil field. But I would like to talk more about like how we can understand it easily. So we start from a wells. So in each well we have some sensors, like we have some sensors checking, the wellhead pressure, or recording the upstream, downstream, even though it's recording the downhole stream. So it depends on how many sensors, or it depends on your oil field, because each oil field have different scenario. Each oil field have different needs. For example, like in which phase you are. So are you like producing a lot of water cut? So in this case, you need some sensors, kind of sensors, like to record or to measure the density of the fluid that you are producing from the well. So in this case, so each field different from other fields. So for example, did you have ICV, or do you have horizontal wells in your field? So in this case, you have more what we call it sophisticated technologies in your field. So you need more sensors to record all that data. So then that data will go to what we call it to a database, or they call it historian database, which is we call it here production database, or they call it PI. Some people call it PI. Some people call it historian database. Adding to that one, we have so this is the real-time database, which is the recording the real-time data coming from your wells. Adding to that one, we have a production database, which is you have a database like to record all the production data that you have. For example, OFM from Schlumberger, they have a database like to record all the events, or some of the events in your fields. For example, the production rates for your producers, for your injectors, kind of data management database for your field. So combining these databases together, and maybe we have another databases to record more data about our wells. So from that one, we can build two different models in your as a reservoir surveillance or as a reservoir optimization. I think there was some lessons or some classes have been presented in this SPE event, like about the digital optimization using using Prosper model, or using other commercial applications from other companies. So you can build a physical model to get the IBM or the IBM curves here, or the decline curve in your field, or you can build on top of that one using those data to build a data-driven models. In our example, machine learning model, or they call the AI models, to forecast your production, or to predict, the events that will occur, especially in your ESPs. Like here, for example, in Iraq, maybe after 5 years or 10 years, or almost like 60% of our wells will be produced by ESP. So you need more, let's say, it's intelligent, what you call it, decision to predict the lifespan of your ESPs, or when your ESP will be down, so you can, bring a workover rig to replace that ESP. So there's a lot of examples on that one. There's a lot of examples. So it depends on your field, as I said, like how many, like for example, your field have a lot of ESPs, so you need to build that models, that data-driven models to predict the lifespan of your ESP, or maybe to record the performance of your ESP, and that artificial intelligence model or that physical model can telling you where you are setting your discharge pressure or intake pressure, to keep the ESP for further time of recording. So in general, this is the digital oil field. It's start from the well up to the dashboard that you have seen here. In between, there is kind of databases. There is kind of RTU, like to try to send the data from the well to the database. Then from the database, there is kind of even though there is kind of what we call it some process on that one, how to filter the data, how to telling the truth of that data. Is that data is the quality of that data, is that data can present good value from that one, or maybe the data there give you wrong answer. So there is a lot of process. There is a lot of algorithms to record that one. So there is a lot of process going on here up until to see the final what we call it, the product, which is the curves. Then you can understand and you can make a smart decision based on that one. If we go back, like 20 years ago or 25 years ago, we have seen many companies starting utilizing the digital oil field terminologies in their fields. For example, we have a Stat Oil. They developed an integrated operation program to exploit deep subsea. So these people, they have a offshore field, so they need to do more. They have some goals on that one, which is to achieve zero environment accidents, minimize human intervention and exposure in high risk and remote areas, and maximize monetary value for the company. So these people utilizing some terminologies of digital oil field to minimize the human intervention on that one. So we will go more maybe in the details in the next slide. But one of the advantage of the digital oil field is to rely on on the technology and minimize the human intervention. And I have seen this one a lot here, like in my work. We are sending some people to measure the wellhead pressure or to measure some parameters from the wells. So that is intervention. So we need to minimize that intervention to minimize the risk of that people of intervention. And even though for zero environmental accidents, because these people working in offshore, so the offshore have a lot of challenges and a lot of risks on that one. So they need to measure some barriers on that one. So the sensors can help them to predict or to targeting if there is any issue on their field. Like in 1998, Shell, which is this company, one of the big companies in the digital oil field, even though in the machine learning, utilization in the oil and gas industry, they introduce a concept of smart wells, which is the smart wells, the IPV, ICD that I said. They installed that one in series of remote control downhole control valve chokes and monitor the protection in real time, which, as I said, is the ICV. The project was expanded, including production operation from multiple reservoir and operational complex activities, which are referred to as a smart field. So if you have ICV or ICD, or even though some people, they call kind of another combustion, they call it LEL. So they call that one is a smart field. So you need more sensors to be installed downhole to get more measurement on that one. So Shell in 1998, they did this project, and it was excellent project as example for the oil and gas industry. In 2000, PP, they made a significant advancement on DOF to produce optimization when the company invested heavily in fiber communication and established advanced collaborative environment with monitoring to centering based on onshore that enabled experts to work directly with offshore operation personnel using a real-time information in a program. They call it Field of the Future. So the people of PP, they're using the fiber optics, to send the sensors data from the wells to the data center to the database. So PP utilized that one in 2000. And they bring, the most edge technology at that time, in the oil and gas industry, and they get some value from that one. So you see, it's the combination of, of a chain of historical improvement on that one, and each company trying, to maximize the most edge technology in their in the world in the oil and gas industry. So you see, ConocoPhillips, they produce this program, even though it's an integrated operation center. They build, integrated operation center to accumulate all that data, all that workflows, all that alarming system management, tank management, visualization, and one IOC, they call it. And then the IOC was also equipped to control wells and facilities. The IOC enabled proactive management and address issues such as production bottlenecks. So one of the big challenges in the oil and gas industry is the bottlenecks. So these people try, to address that issues of bottlenecks and to act in advance using more advanced technologies on their like for example they install what they call it a choke, but that choke is automated. So in the control room you can changing the choke without any human intervention. So you can do your virtual simulations, even though machine learning simulations, and it can telling you to adjust the choke. So directly you can maximize the value of the digital oil field to optimize the production. We will go now to Kuwait Oil Company and Aramco here in the Middle East. So these two people, they utilize now. Kuwait Oil Company start utilizing AI, artificial intelligence, in their field. Even though Aramco, they utilize multilateral wells equipped with smart completion and real time. So you see, they start producing from multilateral wells with a smart completion, and that one need a lot of attention on that one. So they run the smart completion with a lot of sensors, and so to enhance the recovery through in time intervention and real-time full field optimization, enhancing HSC through remote monitoring and intervention, and reducing operation cost by minimizing manual supervision. They are focusing more minimizing the manual supervision and intervention. In 2020, Saudi Aramco had 19 intelligence. So we can say about this statistics. In 2010, Saudi Aramco had a 19 intelligent field in operation. And I believe in 2023 now, I think all the oil field in Aramco, they have a digital oil field on all their oil fields. So we can see all the oil companies, they get the value of that one, and they put a lot of effort. They put a lot of what we call it a capex in advance, so they can get the value of that one to the end life of the oil and gas industry life cycle on their fields. Until now, Haider, so is there any questions, or I should continue to the end? Then if there is any questions, the audience can stop me.
Please, if you have any questions, raise your hand so I can unmute you, or if you can write it in the chat box. Or if there is no question, you can proceed, Mr. Abdullah.
Okay, perfect. Thanks, Haider. So now we will move forward on this chart, this triangle chart. We will talk more about the digital oil field layers that we are talking about. So like, for example, here in Iraq or any oil field, like this chart can telling you what is the phase of your field to utilize digital oil field. Are you in this phase, or which is the manual process, or you are on the automation process, or the RTOC process, or the digital oil field phase, which is the most optimal integrated phase in the oil and gas industry. So we start from the bottom, which is the manual process, which is the definition of that one is 100% manual intervention, which can give you poor efficiency, poor integration, a little collaboration. So this chart is the most important chart in this presentation. I hope you can pay more attention on that one, because you can utilize this chart in your life if you would like to utilize digital oil field, or if you want to evaluate the digital oil field of your field. So you can utilize this chart that can answer your questions on that one. So we start from, as we said, from the zero. So now we have a zero collaboration, we have poor integration, little collaboration, poor efficiency, which is 100% manual intervention. What does it mean, manual intervention? So we don't have a remote sensing. We don't have sensors can measure the upstream, downstream, or even though the flow rate of that one. You don't have a virtualization models. You don't have anything. You're just producing, and you just like recording that one by papers, and that's it. It is the manual process. And I have seen this process in some fields in Iraq. And I believe now we are moving forward, to jump from this phase to the upper phases. The next phase, which is they call it the automation phase. Now we can start see the infrastructure of this phase, which is starting utilizing CAD sensors to measure the pressure and temperature, the pressure of upstream and downstream pressure, and the temperature of the wellhead. Second one, we have a well test data monthly. So we bring, MDFM, or we are bringing GLCC units or any rate surface rate measurement, to record the data by monthly. Now we are starting to diagnose and well actions monthly. So we have kind of, monthly review to do diagnosis and well actions by monthly basis. Non-integrated data transfer and manual processes. So we can see now we jump from this phase to this phase. Now we start, utilizing some real-time sensors using SCADA or Historian or PI system in our field. And we are utilizing some well test data by monthly, and we do some diagnostic and well action by monthly. And the environment, the effects here, we are situational room or office desktop. And here, the value of that one, we are reducing the OPEX reduction. Why? Because, we are recording the pressure and temperature. So we kind of have, some automation on the well status. Is the well is active or inactive based on the pressure and temperature data that we are recording on that one. And the environmental setup here, we need office, desktop, or situational room. I believe now in each field here in Iraq, and not only in Iraq, in all the world, they have kind of a room, like we call it a surveillance team, or we call it a production optimization team. So it depends on the definition of your company, but for sure you have people like keep monitoring the data that's coming from the wells, and based on that data, they make decisions on that one. So that can reduce the OPEX for your field. If we jump more on these layers, we go to the RTOC layer, which is the real-time operating center. Now we are recording pressure temperature. Now we are starting utilizing virtual metering real-time. And the virtual meter, I believe all of you know about the virtual metering, which is basically Prosper model. That's it. Or any commercial application in the industry, you can utilize it to build a virtual metering that can give you the what we call the performance of your well. So not only that one, you can run it by monthly. Now you can run it by real time. I mean by real time, maybe by hourly or maybe by daily. So you can get more integrated algorithms, more integrated applications to do that one for you. The third one is the diagnostic and operations actions. It can be happen bi-weekly. So now we start jumping from monthly to weekly. So instead, review your well performance by monthly. Now you start, reviewing your well bi-weekly. So you can see the advantage of, getting more technology or more digital oil field technology in your field. Then you can get, more and more surveillance on your wells by weekly, not only by monthly. And now we can get, some automated workflows, mostly a manual controls intervention, structured data environment. You need kind of more, bigger with what you call control room, which they call it here operations center, RTOC. And the value of that one is the production increase, OPEX reduction, and downtime management. So in each of these steps, we can go in more details, but basically now we are getting more automation in your field. I mean, here they put it here, we call it some automated workflows. So now you don't need, to let your engineers to spend a lot of time, to give the recommendation why this well performance is getting low. So now you have more workflows, or you have more models now, automated models can give you why, the production of this well now it's getting decreased, maybe because of reservoir pressure, or maybe because of a flow assurance. Maybe you have a scale buildup, or you have asphaltene, or maybe you have some issues in your accomplishments, or maybe you get more, produced water cut. So all that one can be automated, and the model can telling you directly by second what is the issue in your well. So then that effect can affect on what we call the production increase. So if you in advance, if you get, if you diagnosed and you conduct to see what is the issue in your well, so for sure you can increase your production. By that one, if you increase your production, you are kind of have a downtime management. Then even though if a well go inactive, if the well is died, so or sees the flow, then the algorithm, the automated workflow can telling you what is the exact issue in your well. Then you can put a proper plan of workover to bring that well in production again. Maybe if your well is what you call it a natural flow, then maybe the model can telling you directly you need to run ESP to produce that one. Or maybe you need to re-perforate. Maybe you need to optimize your choke setting, or maybe you need to do a stimulation based on the pressure and temperature and all the data coming from the well to the operation center. You can see this one here. If we move more, which is the optimal solution for digital oil field, which is here, you can see the process efficiency, the team efficiency, the production uptime. Now it's got to the optimum, value of that one. We can see now a multiple pressure, temperature, volume, downhole real-time data, real-time coming to us. So now they don't have only a pressure and temperature. Now they are setting a sensors to measure the volume, the mass volume of your well. So we kind of have some sensors can measure that one. And maybe in another session, maybe you can go in details on this one if you like on that one. So the more sensors that you put in your well, the more digital oil field that you get. I mean, don't understand this one maybe in the wrong way. I don't mean, to install all the sensors that in the market. No, it's not that one. But you can make a study on your field, and you can see maybe I need to install a pressure temperature only. That's it. That will be enough for you. Or maybe you need to install a density sensor or volume sensor adding to the pressure and temperature. That will be a plus advantage. Or maybe you are running ICV or ICD downhole smart completion in your field. Then you need more sophisticated downhole sensors to see and to continue doing a surveillance and production optimizations on your well. So it depends on your well. That's it. And the environmental effect on that one is now we can see a more collaborative working environment, and we start utilizing mobile applications. So now even though the operation team that working in the degassing stations or in the refineries, these people is not disconnected from the reservoir and subsurface team. We have seen this one a lot in our working environment here in Iraq, even though in around the world, there's kind of disconnected between operations team and subsurface or reservoir team in general. Like there is kind of the communication happened by maybe by a mobile, or sorry, by email, or maybe by phone call. So that one there is a collaboration, but the collaboration is not to the optimal. Now, if we bring a mobile application that can, showing the operation team, not only the operation team, the reservoir and subsurface team, the plan, the daily planning to optimize the production. So now we have more collaboration on this one. So now operation team, they can more understand why this one happened, why we need to adjust this choke, why we need, to do this kind of intervention in this well. So we do have now more kind of a coordination and more more transparency between all these teams together. So now we have more collaborative. And the value of that one is we can improve a lot the production, we can mitigate the downtime, and we can optimize the production. So all these can be happening here in the optimal of digital oil field, which is now we have more smart and fit to purpose workflow. We have more automated controls and we have more integrated data systems. So now we bring more artificial intelligence models to work instead of the engineers. I don't want to say like we need to replace the engineers. So, but now the surveillance or the production optimization engineers, now they have more tools that can help them, to understand the performance of the well. So, but layer by layer, now the engineer get more, more tools helping him, to get, a smarter or maybe a quicker decision on the well, especially in the oil and gas industry. So you don't need to wait 6 months or 1 year, to review the well performance. As we said, like we start here from this one, from the manual, which is there is no kind of measuring or recording of the performance of the well. If we jump to this automation, now we kind of have some kind of well test but it is by monthly. If we jump to the RTOC, now it's a weekly, but now we can optimize our wells by daily or maybe by half day. We can say that one. So now we have more tools, we have more technologies can help us, to improve our production, to decrease our downtime, and to optimize our performance in all our field. And that all of that, can give us a more, tools in our field to continue producing as planned.
Mr. Abdullah, I have a question.
Yes,
I'm sorry for
yes,
interruption. What is the differences between basic SCADA and the SCADA and the RTOC?
It's almost the same, but SCADA is just like a tool. SCADA is just like a tool, or we can say it's just like a database that can host all the data that you have it in your wells. And the SCADA is different here, Haidar. So sometimes you need to do, as I said, like in the beginning, if you remember, I said we need a filtration, or we need some workflow or algorithms, to check our data quality. Sometimes your sensors stop, sending data to your SCADA system or to your database. So you need kind of algorithm to interpolate between that data. So, the more advanced SCADA system that you are using, the more, the more data integrity that you will get from your sensors, and the more value that you can fit and you can inject in your artificial intelligence or your virtual models to get a better answer from that one. So, for example, in your virtual metering model, let's say a Prosper, if you put a wrong wellhead pressure or a wrong what we call it the water cut, so what will happen? The model will tell you a wrong decision on that one. So before you injecting your data inside your models, you need kind of a filter or a firewall to check the data and to make sure the data that goes to the model is accurate, or at least it's as expected, not below or above kind of what you call a filter window on that one. So this is maybe the answer for this one, Haidar.
Okay, understandable. Thank you.
Thank you. As I said, like let me go to the next slide. This is one of maybe the second most important slide in this presentation, which is the main component of digital oil field. So in the digital oil field, we are relying on 3 components. We are relying on the technology, the people, and the process. All together, collaborated together, can give us a digital oil field. And This here, this this cycle can telling you more in detail what we are meaning by all these components together, and how we can expand that one in 5 components, which is here we have the business needs here, which is the people, as they say, the people, technology, and process here. So we are starting from the remote sensing control, or they called RTU. So we need to install some sensors in our well. So we need some kind of instrumentation. Then we need some kind of a remote choking. So if we need to adjust the choke by remotely, so we need to install some sensors or some tools to do that one for us. And we need a wire, or they called a fiber optics cables, or they called RTU, which is Wi-Fi or transmitter Wi-Fi to send the data to us. And we need the kind of the way how we transmit the data, and how we can get the power from that one. Do we have a power supply coming to the oil to the all the wells, or maybe we can rely on a solar cellar energy to do that one for us. And definitely we need security on that one. Security, to secure the data that we get, is so we will not, get a kind of a cyber attack coming to the sensors, coming from the sensors to the database, and that maybe can affect and can harm and make impact what you call it, the disadvantage for us. So we need, to get all these together in the first phase, which is we call the remote sensing control. Then if we move forward on that one, we come now to the data management phase. Now we need kind of data architecture. We need data storage, data cleaning, alarming and alerting, and we need kind of KPI monitoring and data analytics workflows. So if we go more in details on this one, as I said before, the data coming to us, we need, to integrate that data, and we need to torture that data if the data is accurate, if not or not. So we need to build that one. We need to build a database that hosting that one, and we need, how much storage we need for the data that's coming to us. So, for example, if your field have 100 well, is different about a field have 2,000 well. 2,000 well definitely need more storage to hosting that data to us. We need to clean the data for us. Sometimes the data coming from the sensors have spikes, or it's out of range, or maybe it's missing. So we need kind of missing on that one. And sometimes we need to set up alarming system or alerting system in our database. So if the data go above or below a threshold that we set up, then it will give us alarm. Then we have a team that can monitor all the sensors that we have, and they have kind of a KPI dashboard. So for sure, I believe there is some applications that some commercial companies giving this one to us, so they know for sure which sensor now is down, which sensor is working as expected or within the threshold that we set up, and then finally it can give us a data analytics dashboard, basic dashboard. This is more for the data management. It's not about to analyze the data and get a reservoir, or we call it subsurface production optimization value from the data analytics. That one, it will come here to the workflow automation. Then if we make sure the data is accurate and the data as expected, then we can build a numerical analytical models. We can build an intelligent component, statistical analysis, and process optimization or virtual optimization. So all these optimization can build in this phase, which is we call it the workflow automation. This workflow automation consists of the data-driven models, the AI models, or the virtual models that we can utilize. All that one happen in this phase. If we move forward on that one, so then if we build the data, the data model here, we need kind of, visualize that data on a charts, because the human eyes cannot, make, easy way to, to answer the data if it is coming only as a number. So we need kind of visualize that data as a mapping, or like for all the field, or as a dashboard. And we have some, a lot of different dashboards or different charts that we can build on that one after the data mining. So as I said, like there is a lot of technologies can build this one for you. You just need, to put what you call your needs and your oil field, then you can build the dashboard that you need for that one. Finally, which is the collaboration. If all this one happen, so we can, transformation or change management, and we can say we are one team. As I said, like the reservoir or surveillance team, they are kind of disconnected from the operation team, but now you have, one team rule in your field, and you have more collaboration on that one. For sure, you need to manage your knowledge that you, and you need to, for sure, to share it between all the people that working with you. And for sure, you need a training, for different disciplines, starting from setting the sensors, to the data management, to the workflow, to the visualization. And all these phases need, specific people for that one. And for each specific people of these phases, we need to define the rules and duties for each people in this one. And you need to give them the proper training or skills training for each phase of this one, so they can work as this workflow can work as expected. For sure, you need, kind of people, more specified on the data management to build their data or the data storage, or to put, cyber security or alarming system on this one. So for sure, you need, a data what we call data engineers, or IT engineer on this one. And for sure, in each section of this one, there is kind of, more specific requirement, and need to fulfill this requirement by the proper team that you need. And for sure, you need to provide them the training, the training, to do their work. And for sure, if we move forward, in the numerical model or the data-driven model, for sure, you need people, to build a machine learning model for your data, or you need a team, to work on virtual metering models. So for sure, they need to have more experience in the reservoir section. So all these phases, as I said, and if we go in more details, you will see, you need a lot of people, a lot of group of people on this one. So as I said, like before, in the beginning, we tried to reduce the human intervention, but that one in the field. But if we go to the control room, or if we go more to the offices, we need to build, a sophisticated team to handle each role of these phases. Then we have, at the end of the day, we have a collaborative people that can work all together, to build a digital oil field system in our field. The value of the digital oil field, I believe I talk a lot about that one, but this is a summarized slide of that one. So we start with reducing the risk that we have. So reduce the risk and minimize the exposure of operators and professionals assisting in the workplace injury. The ultimate objective is to achieving the zero accident performance. This is invaluable. So, in the oil and the gas industry, the main concern for all the IOCs or for all management is how to minimize the accident, how to achieve zero accident performance in our field. And I believe digital oil field can help a lot on that one. And I have seen in some fields, they put what we call it in their field, they put even though a drones. So they have a routine drone flying to the field, and the drone sending a pictures or a video stream to a data-driven model. That data-driven model can analyze the data and can telling you if there is a spill or there is a leak in on one of your flow lines. Then you can, you can reduce the impact of your environmental impact, and that's, it's valuable as well to the zero to the accident that can happen in the field. The second one is the protection uplift. Monitor reservoir decline rate or water flooding for sure. If you have a water injection or water flooding system, so you need, monitoring that one to increase the production uplift on that one. Detect real-time production deviation from plan for sure. As I said before, sometimes you have a scale deposition or you have asphaltene deposition on your well, which is we call the flow assurance. So that's a real-time production can telling you, for example, maybe your expectation for your for this well, for X well, it's 2,000 barrel per day. But in the while your model is working, your model detects that the production now became maybe 1,000 barrel per day. So it's mean there is kind of issue there. So your model can detect that one for you, and for sure, if you have more intelligent application in your field, then even though that intelligent application can telling you what is the exact issue, what is the exact problem that you are facing in your field, then you can put the proper workover plan for that one. And the last one on the production uplift is to determine opportunities to increase production. Each field, they have a bunch of lists for what you call it idle wells, or they call it, wells have been shut in for a long time, and you need to a proper plan to bring those wells into production to increase the production uplift of your field. And that models or that workflows of digital oil field can help to determine the opportunities to increase that production. So this is the second value of digital oil field. The third value of digital oil field, as we said, is the work process efficiency. Now the data can be sent in real time to the operation system. Now the data can be stored in structural database, which is what we call it SQL or SQL database. Automation boosts the entire manual workflow. And we have been talking about this one a lot in the previous slides. So the more automated workflows that you have, the more work process efficiency that you get from your field. At the end, the more production uplift and the more reducing cost in the OPEX of your yearly cost of your field. Lastly, the team efficiency. Now, I believe all of you agree with me on this one. Like 60 or 80% engineers are spending their time on data collection and management. I have seen this one a lot in my work, like in the last 6 or 7 years. I have seen the reservoir engineers spending almost 80% of their time just to collecting the data. They need to collect, the open hole log, the cased hole log, like for example, the historical BLT data. If you are running, a BLT log each year, so you have, kind of 5 BLT logs. If you're running, a web test each month or each quarter, or even though each half a year, then you need to collect all that data. You need to collect, the salt measurement or the water cut measurement for your well. You need to collect, the behavior of the wellhead pressure from the sensors. So all that together need a lot of time, to collect. And then at the end, you need, to analyze that data to make a decision about the efficiency of your well. In this case, if you're utilizing digital oil field, all that 60 or 80%, it's eliminated. Then the engineer, the reservoir engineer, or the subsurface engineer, or even though the operation engineer is depends on, the objective of your digital oil field. Now they can spend 100% of their time to review and do a surveillance on their wells, because everything now is built on top of that one. Now they have the proper charting, they have the proper workflows, the proper virtual metering automated system that they can get the data by real time. All the logs now can be hosted on a database in one click. Now you can present all the well history of that or for a specific well in one click. So then you can spend all the time that you have, to optimize the production for your wells. Second one is spent more in troubleshooting, as I said, addressing performance issues. And lastly is the managing by exception. I have seen this one many times in a lot of oil fields. Management need to manage by exception. The management no need for the management to continue monitoring the daily activities. For example, the management, they don't need to check and to send a decision for the subsurface team or for the well work team, to do for example a specific or a basic work, like for example they need to work to do more and to lift let's say for example and to lift operation in the field to increase the production, or maybe you need to bring more workover rigs on that one. So that one or maybe you need to do more what we call the PHP jobs, surveillance jobs in your field. So that's a routine job. So the management they don't need to involve themselves on this one. They need to involve themselves more on only by exception. I mean by only to put the proper rules to make the digital oil field working more efficient. Like for example, maybe we need to automate this process to make a better decision. So the management now they have a time to make a decision for bigger, what we call bigger rules or bigger plans for all the fields. So this is managed by exception. So it can increase the team efficiency, even though for the management or not only for the engineers. I believe that's all I have, team. If you have any question, please go ahead. Haidar?
Yes, so I myself have a question. So
Mhm.
due to digital oil field process, is there
Mhm.
any uncertainty percentage due to the lack of a human interaction? Is there any uh, uncertainty or maybe something?
For sure, uncertainty it's always exist in the oil and gas industry. So in the oil and gas industry, because we are working with a reservoir, it's away from us 2 kilo, 2,000 meter, or maybe 3,000 meters. So for sure, the more data that we have, the better decision that we can make to optimize or to manage our field. So for sure, if you, as I said, like if I go back here to this chart is good, to answer that one maybe. So so now we can see, like here we have a manual intervention. So we don't have, even though sensors that can be sent by SCADA system to the engineers in the what you call in the operation room or something like that. So now we have a lot of uncertainty on that one. If we jump directly to the DOF, now we have a multiple pressure, temperature, volume sensors. Not only that one, even though we have a downhole real-time data sensor. So from that one, we can understand more, our reservoir. From the downhole sensors, we can understand which zone is producing more water, so we can control that one by ICV, by closing or open more the valves, or maybe we can measure the reservoir pressure if we get a decline in the reservoir pressure. So for sure that one can help. As I said, like in the oil and gas industry, if we go back here to this page, I believe, which is here, data is the new electricity. The more data that you have, the better model that you can build, the better decision that you can make in your daily basis working.
Understandable. Wonderful. So I have another question. So you said about you mentioned cybersecurity. So how does cybersecurity concern the impact or impact the development of the operations and the of the oil of the digital oil field, and what measures are taken to mitigate potential risks?
Okay, perfect. Thanks for this question. Let's go back here to this one. Okay, here I believe I mentioned here in the security in the remote sensing control. I believe if you remember, I think that in maybe 3 years or 4 years ago in USA there is a cyber security attack in one of the production line of that one, and that cyber security attack have been stopped the the production line. It's a main production line, so it have a lot of flow lines. So that give virus decision to that model, and the system there have been stopped, shut down, and all the production in one of the area in one of the fields in USA have been stopped. So we can see, like, if you get a wrong data. So as I said, if you build the machine learning models on that one, so you need kind of to protect that model from the wrong data. And adding to that one is the oil and gas industry data is very sensitive, so you don't want that data goes to the wrong people, or to any group of people that your field doesn't want to go. So your field, if you build you know if you are trying to send the data by what you call by Wi-Fi or by transmitters, we call the RTU. So you need to make sure that the data goes to the proper database system, goes to the desired server that you built on top of that one. You don't want to hackers to hack your system, and they can't steal in your data, because you don't want to what you call it, to share that data with anyone, because the well data is very valuable for the operator who's operating this field. So this data is sensitive, and you don't want to share it with anyone. It's not only that one, you don't want what we call it, to make faulty data, or even though to stop the system that you build on top of that one. That's which is we call it the SCADA system. As I said, data is everything. So if you don't have a data, it means your digital oil field will be useless. So in this case, you need to make sure the data transmitted smoothly by real time to the desired database SCADA system. And I believe there is a lot of firewall, there is a lot of rules and the protocols you need to follow to protect your data from all that one.
Understandable. That's wonderful, actually. So I meant to ask you more about this slide. I noticed there's something about data management. It's called the data cleaning. What is the meaning of data cleaning? There's a faulty in this data, or it is maybe uncertain, or what's meaning by the data cleaning?
Okay, good question here. So data cleaning, maybe only for this word data cleaning, maybe we need to spend 2 hours just to explain to you what is the workflows that we are utilizing. So data cleaning, can be expanded into multi-layer, what you call multi-layer rules. For example, as I said, sometimes your sensors starting send data, or there's kind of missing data between the events. So for example, your sensor stop sending data in 5 minutes, or maybe in 2 hours, or maybe in a day. So you have a gap on that data. So how you can fill that data? There is kind of a lot of rules, or there is a lot of ways to fill that data. They called imputation. So you can build a machine learning model to fill that data, or maybe you can use the mean, or we call it the average of that data on specific events. So you can't set up kind of algorithms. You can write a code, or maybe even though the SCADA system have that abilities, you can just like drag and drop, like to telling the SCADA system if you have a missing data, then you can utilize, let's say, you can use the mean or the average of that data to fill that gap. This is, one rule. Second one, maybe sometimes you are receiving data, but the data is out of tolerance, or the data is below or above a threshold that you set up on your data. For example, your wellhead pressure, your expected wellhead pressure, let's say, for example, it's 300 psi, okay? But suddenly you are start receiving wellhead pressure with 1,000 or maybe 2,000 or maybe minus 10,000. This one means the sensors is not working. This means the sensors have some issue. So so you need to clean that data. You cannot send, as I said, you cannot send that data to your virtual or your machine learning model. So in this case, you need to what you call it, to set up algorithm or workflow again to check if the data it's out of the range or out of the threshold that you set up. Then you can, let's say, for example, use the mean value to fill that spike data, and etc. etc. And there is a lot of issues in your data. For example, again, the wellhead temperature. The wellhead temperature goes up and down in the day and in the night. So it's kind of spiky. It's like a sine wave. If you are looking for a wellhead temperature data without any filtering, you will see the data is kind of sine wave. So you need to minimize that noise in your data because of the sunlight. Because of in the day the temperature will rise up, in the night the temperature will decline. So you need kind of what you call it, a filtration system to filtrate that data, so it can give you exactly what is the wellhead temperature by excluding the effect of the outside temperature, which is if you are in the day or in the night. So you can set up algorithm or workflow to filtrate that data. So this is another example here, Haidar. So this is what we mean by data cleaning. So without a proper data entering to your models, your model will not be working fine. So this is
Yes,
basically what we are mean by data cleaning.
yes. It's rubbish in and rubbish out, right?
Yes, yes, rubbish
Rubbish
in,
in.
rubbish out.
So you mentioned
Yeah.
also about data monitoring. Do we have the means, or what are the means to do this? Do we do system of Internet of Things, or uh, how do we monitor the data? I mean, you can monitor these sensors. How 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 the data is transferring to and from?
Okay, maybe you're I think it's in the same section of data management. I mentioned about that one. So sometimes either you have a 1,000 well, or let's say, for example, you have a 500 wells. In each well you have maybe 3 sensors. So your team, it will be really difficult, to check all the sensors by manually. So you need kind of a software or application to check the integrity or the status of that sensors. So by means of that one, which is the KPI monitoring, I mentioned it here, that application can telling you which sensor is down, which sensor is good, even though in those sensors there is kind of a battery. So that battery have a lifetime, before running out. So you need that recording system or that KPI monitoring system can see if there is if this battery, let's say, it will be run out by next week or by the next day. So these people who is responsible for this one, he can make a daily plan for the operation team, or for any people who is responsible, to install and maintaining these sensors, so that he can't telling them we need to change the battery for this sensor, or this sensor is not working fine, so we need to replace it again. And from that data cleaning, we get a lot of spikes. So this sensor is not working as expected. We get a lot of downtime from that sensor. We need to replace that sensor, or we need to check maybe the sensor is plugged because of debris or something like that. So it's needed cleaning, or maybe the sensor is not working. You need to replace it, or the battery need to be replaced with a new one. So all that one is under KPI monitoring. So as you said before, if we have a rubbish data goes inside, we have a rubbish data will go outside. So we need kind of this kind of monitoring system for the sensors and for the data that coming to from that sensors.
Understandable. This is wonderful. Actually, I've enjoyed every minute of this session. So, people, if you have any questions, please raise your hand or write it in the chat box. So, Mr. Abdullah can answer you. So, let's
Yes,
wait for
please.
the question.
Mhm.
Apparently, we don't have any questions. So,
Okay.
I guess we have reached the end of this session. I'm really grateful for you, Mr. Abdullah, and we are very delighted to have you here in this session. And actually, I enjoyed every minute of this session, and I really have more questions about it, but but I don't have time. So people, I'm grateful on behalf of myself and on behalf of SPE student chapter and the participant chapters. We are grateful to have you here, and thank you for the precious time and for the precious information. And I'm grateful for you and for Mr. Ahmed Jarrah. Uh, we are delighted to have you here, Mr. Abdullah. Thank you for everything that you just provided. Uh, that's it.
Thank you, Haida. My pleasure. Thank you. Have a good day.
Thank you. Have a good night. Goodbye.
Thank you. Thank you. Bye.
People, you can register your attendance and the link provided in the chat box. Please register your attendance. Please register your attendance in the link provided in the chat box.